So, hi everyone. My name is Sebastian. As I was already so wonderfully introduced, I am a developer advocate for Kotlin, Compose multi-platform, and many other things at JetBrains. And if you've ever noticed me anywhere, yeah, you'll notice that most of the things that I do in some way, shape, or form relate to Kotlin. It's pretty much what my entire day is filled with. And today, I wanted to talk about a topic that's very near and dear to my heart, which is the Kotlin standard library. So, depending on from what perspective you're coming in, I might be taking you back to the standard library. But even if you haven't written a lot of Kotlin, I hope that you still get something out of this talk. You know, you can evaluate for yourself whether the grass is greener on the other side, and kind of just see what we have going on in our standard library. The reason why I think the standard library is so special is because it covers so many things just right out of the box. We really have a ton of assorted goodies. And for me, as an English as a second language speaker, I really love the word assorted because it can mean both sorted as well as mixed, which I guess kind of works because in the standard library, we cover a lot of different sectors of things that you might want to work with in a general purpose program, but we also cluster them in a way that they are easily discoverable and that you can work with them. But of course, the Kotlin standard library provides you with tools, and tools you can only use if you are aware that they exist. Now, photographers like to say this thing, which is the best camera is the one that's with you, right? There's no point in having a $10,000 rig sitting in a studio 1,000 kilometers away if the moment that you want to capture on film is happening right where you are, and the only thing you have is your phone, right? Then that might be the best camera. And I personally would posit that honestly, with libraries, it's kind of the same thing when you think about it from the perspective of programming, because the library that you always have with you, the standard library, kind of defines the vocabulary that you can reasonably expect most developers of that programming language to be familiar with. And in addition to this, you also don't have to get into any kind of extra arguments, because there's nothing extra that you need to add to your project. You don't need to update it. Don't need to ship anything extra. It's just there with you. So the fact that it's a shared vocabulary is something that I think is really important, and why it's really worth kind of looking into what the standard library really offers. Because wherever you go, whether it's your hobby side project that you're working on during a weekend or something like this, or you're working on a huge enterprise code base, the functions and classes that you have available to you in the standard library are always going to be there. In the case of Kotlin specifically, one of the other nice features is that just through the design of how these classes are typically structured, they naturally nudge you towards a more idiomatic style. So you automatically write Kotlin a little bit more like someone who you would consider like a native Kotlin speaker, right? It nudges you in the direction that the language designers originally intended. So really, if you go back to this craftsperson analogy, it is this personal tool belt that you have with you wherever you go and wherever you're kind of working with it. Now, there's a ton of different features in the Kotlin standard library, and I will not be able to give you a comprehensive overview. It's just not enough time. So I wanted to specifically pick out some of the features that are typically less covered in the materials that you might encounter when you first look into Kotlin. So we'll be talking about collections, we'll be talking about scope functions, builders, and delegated properties. So I hope that all of these topics will be interesting to you, regardless of whether you've already written some Kotlin code or this is kind of your first touch points. And we will dive right into collections, which is, I would assume, the beating heart of most standard libraries, simply because, well, as programmers, what do we do most? We wrangle some kind of data that happens to be in some kind of structures. Those typically happen to be collections. We're going to look at better ways of how you can create new lists and collections. We're going to talk about how you can transform collections, so turning lists into lists of lists, or turning lists into maps, turning lists into sets, these kind of things. We will also be seeing me writing a little bit of a love letter to my favorite function in the Kotlin standard library. And because I, of course, want to keep your attention, I can also do a little bit of clickbait, and I will be able to tell you about the data structure in the Kotlin standard library they don't want you knowing about. Or, well, one that's at least not typically introduced. We'll get to that as well. So, typically, when people introduce Kotlin connections, they usually throw up this image, which has a lot of like arrows and shows a lot of like relationships between interfaces, classes, and implementations. It doesn't really, like, all the boxes don't really matter. The main point here is that we in Kotlin have lists, sets, and maps, the traditional types of data structures, and these also have mutable versions. So while list, set, and map are read-only, mutable list, mutable set, and mutable map are changeable. And today we are going to focus a lot on kind of the transitions between some of these data structures, plus that extra one that I don't want to spoil. So originally, the concept for this talk was just a huge stack of PowerPoint slides, but, well, it is IntelliJ IdeaConf, so I figure we just leave the presentation tool straight away, and we just start actually writing a little bit of code just in IntelliJ over here. I already had a cup of decaffeinated coffee earlier, so thanks to the placebo effect, I think I should be energized enough that we can get through most of the topics that I have planned for today. Okay, and we'll start very simple with a little bit of a warm-up. If I just want to construct a list in Kotlin, right, I could do that just by using list off. That is the typical approach. And then that'll just give me a list. I can print that, and I can see these kind of values. So far, so good. What could you possibly critique about code like this? Well, even in this tiny code snippet, we already have a little bit of duplication going on, right? Because implicitly, I went in here and I kind of wrote the first, second, and third index out, which means that this code doesn't really scale, right? If I want to have 100 indices, that might already be a little bit more difficult. Well, in the Kotlin standard library, we have the wonderful capital L list constructor that takes a size and a lambda that determines how to initialize an element. So what I could write is, for example, a list of size 3, and then I'll give it the instruction of, well, give me the exact same string, so just with the index, and put that in each element. And if we run this, we will see we get almost the same. I have established my credentials as a programmer now. I have done my first off by 1 error. So if we just add a little bit of an it plus 1 here and we rerun this, we get the exact same result. Wonderful. With this small change, our code is all of a sudden now a lot more scalable. I can now just have 30 elements and they do the exact same thing that I did beforehand, and so on. The wonderful thing is that this also works not only for the read-only versions, but also for the mutable versions. I like spending my afternoons sometimes playing these kind of word-guessing games. I don't know if you've maybe played Wordle at some point. The concept there is that you kind of start with 5 unknown letters, and then afterwards you might start doing some guesses. So, for example, you might set the 0th value to C, or the 2nd value to A. And now if I run this, you will see that, well, I get something that kind of looks like a word with some placeholders. Well, I'll be honest with you, it kind of doesn't really look like a word yet, but thankfully with the Kotlin standard library, I can just use join to string. I'll say the separator between the individual elements should just be empty, and all of a sudden, that looks a lot more like something that I would put into some kind of like guessing game, right? And this is also where I do just want to go off on my wonderful little tangent here, because I have to say join to string is probably my favorite function in the entire Kotlin standard library, for multiple reasons. First of all, what I really like is that it nudges you towards showing intent, right? Rather than writing like a loop or concatenating things together yourself, the only thing that you need to read is, well, join toString. Give me a collection and join it to an individual string. And what people, I think, oftentimes miss is how many things this function can actually do. So let me just quickly go back, and we'll go back to just a list of numbers. We'll create ourselves a string using join to string, and then we'll print that. So now if we take a look in here, we can actually see that there's a ton of different both arguments as well as transforms that we can add to this, right? So we can start with a separator. That one we've already seen. We can provide a prefix to our list. We can provide a postfix. We can also provide a limit if we have 5 elements in our list or 100 elements, but we're really only interested in the first 3. We can do that. Everything else we cut off using etc. And then we can actually go in and we can provide a lambda. So we can provide a function that determines how the individual element is transformed before it's like concatenated into each element. So rather than having all the individual numbers, we could actually add their reciprocals, so like 1 over that number. And if we print all of this, you will actually see that we get the exact kind of string that we might want. And we never had to spend even a split second thinking about, well, if I add a separator, do I have to drop it at the end? I didn't have to manage a string builder, but I still get the same kind of performance out of it as I would. Things like limits and all these things just work out of the box. This pattern, by the way, is also one that I'd really like you to pay attention to as we go through other things. Having a lambda that's kind of trailing the function, that still does some kind of transformation, is something that you'll see a couple of times, right? Here it was for initializing the individual elements in our list. Here it's for changing the way that an individual item is represented in our string. Why I love this so much is because whenever I see functions like join to string, rather than like having some kind of loop or using some kind of other methods of manual concatenation, is that I get to engage the vocabulary side of my brain, right? I just read join to string and I know what's happening, rather than using the like pattern matching side of my brain, where I would have to like actually like look at it and be like, well, based on the shape and based on the variables that are in here, that's probably just concatenating the entire string together. This is a little bit more elegant, which is why it's probably my favorite function and something that I really enjoy showing off usually. But okay, this was a tangent, and we were only like in the kind of warm-up session at this point. So let's actually take a look at some more standard library functions. Let's say I have just a list of students here. I'm a middle school teacher, and I'm tasked with essentially separating these folks into pairs so that they can do some kind of group work on homework, or this kind of stuff together. In Kotlin, we can do that using the chunked functions, for example, with a chunk of size 2. And if I run this one, you will see that it gives me exactly these kind of pairs. So it kind of like chunks off individual elements with no overlap. So you'll see that it's Anne, Joe, and then even Leah. And then, well, I don't know how popular all of you were in middle school, but then there's Max who just didn't find a partner. Luckily, the Kotlin standard library can even solve this problem. We have the shuffled function, which we can just call. And at that point, at least we can ensure that it's not Max every single time. If instead we actually wanted to use a sliding window, we could use the windowed function. So this one essentially moves a window of the given size over your list. So we can just see here that Anne, Joe, and Eve is the first one, and then we move the window 1 over. So we're getting duplicates with Joe, Eve, and Leah, and then Eve, Leah, and Max. Now, of course, if you squint a little bit, you could make this work with the middle school example where you say, okay, so Joe's neighbors are Anne and Eve, Eve's neighbors are Joe and Leah, Leah's neighbors are Eve and Max. But that might still be a little bit contrived. So there might be, but it's still quite useful, because let's imagine that we're getting a bunch of values, for example, from a temperature gauge, right? Some kind of sensor. And I hope that these are in Celsius. That would be a good assumption. Otherwise, if these are in Fahrenheit, your heating bill is going to be enormous. So, but we could use this to create kind of a sliding average, simply by going into our temperatures and then saying, well, I'd like to have windows of size 3, and then the pattern reappears. We can actually add a lambda that transforms each individual window into another value. So we can just say, give me the average of each window. Doing that, we can see that for the first 3 days, where it's still kind of like moderately warm, we get about 16 degrees. And then at the very end, when we get a minus 13 degrees, the average is really cooling down. This is, of course, really neat because, as you can see, Kotlin just kind of provides extension functions out of the box for a lot of typical use cases. If you have a list of doubles, it's reasonable to assume that you might want to create an average of that. But of course, this is also a great time to show off that with just a bit of regular Kotlin syntax, we could have also just split our entire list into 3 individual variables, and then we could have just done a little bit of middle school math to get the exact same results. Both of these work. It's just wonderful that these things are already in there. Okay, I think that kind of concludes our warm-up about just like manipulating lists and just like playing around with them for a little bit. Now we'll get to a slightly more interesting topic, which is maps, and specifically transforming lists into maps. That's interesting precisely because, well, a list is usually just kind of a loose collection. But in a map, you always have key and value pairs, right? That have some kind of relationship. So where do you get that relationship from if you just have a single list? Well, the answer is usually that you would make some kind of association between the thing in your list. In our case, that would be the string, and so a property of that thing. So, for example, we could say that our map is just the colors mapped. And we can say, for example, we use the actual text in uppercase as the key, and we'll use its length as the value. Okay, out of the box, just using the map function, we get a list of pairs. But if we think about it, what's a list of pairs if not essentially a map? So we can just call to map, and we get this kind of conversion. However, this code is still kind of weird, because what's happening here is, well, we're kind of creating this list first, and then we're converting into a map. It's not very clear what we're trying to do. And more importantly, it's also not very performant, right? Like, you're first creating some intermediate collection, then you're doing something else. IntelliJ luckily already tells us that there's a better way to do this using the associate function. So the associate function does what we just did manually. We just create pairs of keys and values, and then we can kind of get a map directly out of that without the intermediate steps. Oftentimes, you would just not even change the key. You would only change the value. So you would have code that kind of looks like this. And at that point, once again, IntelliJ jumps in and tells us, hey, there's a more specialized function here in the standard library. You got to brush up on your vocabulary. And that one is associate with, which you can read exactly as you kind of would if you say it in natural language, right? We take each of the colors, and each one we associate with its length. So red is associated with 3, blue with 4, and so on. You can also flip this around into the other direction, where instead of saying, hey, for each of my colors, generate me, for each of my colors as a key, generate me a value that's length, you could also say, well, for each of my colors as a value, associated with a key that's generated by the length. So that's the associated by function. That kind of goes into the opposite direction, and that gives you probably what you would expect. So you have 3 to red, 4 to pink, 6 to orange, and so on. This list, interestingly enough, is one shorter, though, than the previous one. And that's because, well, if you have a map, then each key has to point to a unique element, right? So if you have both blue and pink, one of them is going to overwrite the other. Of course, this might still be okay if you are already aware that you have kind of a uniqueness constraint. Otherwise, we have the group by function, which does exactly what you would expect. And this time around, you just get a list as the values. So in this case, we get 4 pointing to both blue and pink. Wonderful. Great. So this was our tiny excursion into maps. Next up, we can talk a little bit about sets. So If you've, throughout your educational career at some point, have already come across like set theory in some kind of way, then you should feel right at home here as well. You can construct sets just using the setOf function. The properties of a set are, first of all, that the order in which the elements appear don't matter. So red, green, and blue is the same as blue, green, and red. And duplicates also don't matter. So if I actually had 2 times blue in my favorites, you would see that printing it, I only have red, green, and blue. I only have 3 elements. The real power that comes from the sets specifically in Kotlin is the operations you can do with them. For example, you can do a union. So for example, you could say, give me all the colors that are in my favorites as well as all the colors that are in my theme, and create like the set that is the union of the two. And that gives me, of course, all of them, ignoring the duplicates, because our result is still a set. If you haven't written so much Kotlin, this might be a little bit spooky to you that I keep on just writing specific words between 2 operands. The reason for that is because these are infix functions. So the less spooky version of this would be just a regular function call with a dot and parentheses. But these are just special functions that are annotating using the infix modifier that allow you to put them between both the first receiver type and the second receiver. And there's nothing like special about this. You can build your own operators that behave the same way as well. That's how we kind of can do things in Kotlin. You can also have some other functionality. For example, you could do an intersect, which gives you only the elements that are in both the favorites and the theme. So I don't know if you need a highlight color or something that's still tailored to the user. And you can also take your favorites and subtract the theme. So that'll give you everything in the theme that doesn't also appear in favorites. Wonderful. One of the things that's interesting about this is that actually these aren't just set operations. You can use these even if your input is just a bunch of lists. So this still works. What you need to keep in mind, though, is that the return type of these functions are still sets. So if you're expecting these operations to keep duplicates, then you're in for a rough time. But apart from that, hopefully you will find these useful. Okay, well, it's already been quite a whirlwind, and I've probably stuffed a little bit of knowledge into your brain, hopefully, so it's time for a small reward. It's time to talk about the data structure they don't want you knowing about. And that one is the ArrayDeque that we have in the Kotlin standard library. Now, first of all, you might be looking at this word, and you might be thinking, well, is he pronouncing that right? Isn't that, couldn't it be like deque? Well, let me tell you, it's the only, I think, the only class in the Kotlin standard library that comes with a pronunciation guide. It is usually pronounced deque. And of course, there's a little bit of another spoiler right in here in the doc string. This is a double-ended Q. So what's the deal with a double-ended Q? Well, actually, pretty much you can just kind of think about it as a mutable list. So it's just a thing, it's just a collection where you can put in elements. What's a little bit special about it is that it has these 2 functions called add first, where you can add something at the first position, as well as add last, where you can also add something. And then, of course, I can take a look at this deck and I'll see that these things have actually been added. Well, now you might be saying, well, if I just had a regular like list or an array list, I could also just call like deque.add, and then I'll just say, well, at index 0, add some kind of element. The difference here is one of performance. With a regular array list, the kind of internal assumption is that the list grows like kind of as the indexes grow. So if you ever add an element at the beginning of your list, what has to happen is you have to kind of take everything that you already have in the list, you have to copy it over in memory, make space for that new element, and then insert it. That's not very performant. ArrayDeque, a double-ended queue, is kind of aware of this use case. So it specifically provides you with the functionality and holds memory in a way where you can actually have things added to the front as well as to the back. This is granted a slightly more specialized data structure, which is probably why it doesn't show up that much in a lot of the documentation or like intro materials. But especially if you're diving into some kind of problems where you're working with like stack-like data structures, maybe give the ArrayDeque a little bit of a view and see if it might be useful for you. Okay, wonderful. So with that, we are going to move on to our next subject, scope functions, after I've had another sip of my decaf. So if you've written some Kotlin at some point, I don't know what your initial gut reaction is when someone says scope functions. I think some people are kind of shuddering a little bit because I think they're frequently misunderstood. Let's say it this way. Scope functions, depending on how you count them, there's like 4 or 5 of them. Let, apply, also, run, and then maybe also with. And all of these functions are used to do something in a given scope. Where the confusion, I think, stems from is that their signature is quite similar. But as you'll see, they're actually used for vastly different topics. So I'm hoping that I might be able to actually clear up a little bit of confusion here. So generally, the structure of a scope function is that you have some kind of object. Here, that's x, and then you call a scope function foo. And then there's 2 things that can happen. You have a way of accessing x within that scope, within that lambda, and you get something returned. And this is exactly where the scope functions are different. Some of them allow you to access x using it or a name parameter. Some of them introduce it as the receiver type of the block, right? So it would be like a this. So you could just access any properties the same way as if you were like in an extension function or like a body of that member. And they also differ in the return type, because some of them give you back the original object x, and some of them give you back the result of the lambda computation that you've done. And while this is just kind of like a little table here, they very much differ in intent. I will go through a couple of examples to kind of help you put these into context, but also if you want to go over these kind of things in your own speed, this is the one moment where I do a tiny little bit of self-advertising. Together with a couple of colleagues, we're currently in the final moments of getting Kotlin Action 2nd edition ready for print, and it also contains wonderful tables like this one, where you can kind of go over the topics that I'll be brushing through here or rushing through here at a more leisurely pace. All right, enough of that. We're going straight back into the IDE, and we're going to have a look at our individual different kinds of functions, starting with let. So I always like having some kind of semi-realistic scenario, so I've brought us a little bit of code here. Concept is pretty easy. We have a function that can give us an address, and we also have another function that allows us to send a notification to that address. Well, we run into a bit of a problem here because getNextAddress gives us a nullable string. So this value might be null, and the compiler is going to be complaining. If you've written any Kotlin, you know, of course, that you could just use a double bang to just kind of brute force this type. You could use the Elvis operator with some kind of error message to error out, or use any of the other mechanisms that are built into the Kotlin language. What's probably a more traditional approach, though, would just be saying, well, if the address is not null, then perform this operation. And that's great. That's wonderful. This works because of Kotlin's smart casting system, so it actually knows that address cannot be null in here. But it becomes a little bit problematic when the function you're calling also returns another value, right? Because as you can see here, this actually returns some kind of confirmation. And I'd like to actually be able to assign this confirmation to a variable. Now, in Kotlin, wonderfully, this isn't actually entirely impossible, because if in Kotlin is an expression and not a statement. So I can actually provide another branch here, and I can assign this value where it says, well, if it's not null, then you send the notification and you give me whatever that returns. Otherwise, you return null. But this code is kind of ugly, right? Like, again, you would look at this and you would be thinking, what's really going on here? What you really want to express is, I'd like to have some kind of code block where my address that I'm getting from getNextAddress is available as a non-nullable string. And then I would like to be able to use that and actually manage to get the value out of this as the operation is run. And that's essentially, these two code snippets are exactly the same, but this one uses let, which is the exact kind of scope function that we were thinking about. So let you use if you have a code block or some kind of computation that you only want to run when the object in question, in our case address, is non-null. You will see that this is actually quite hard to mistake for our next scenario, which is apply. So we're completely switching context here, and we're saying, okay, we have some kind of like network client that we're working with. And of course, to use that client, we first of all have to construct it somewhere. This could be in a class body or somewhere else. And then before we make our first request, we actually need to do a bit of setup. We set some kind of token. We make sure that our stateful connection is actually established. We make sure that we authenticate. And then finally, we can actually make our get data request. In this example, that's all fine. The problem is that the moment you write real code and you have a whole bunch of other functions, methods, and whatnot, it's probably looking a lot more like this, where you are initializing the object in some place, and then way later, you're actually doing the real setup of the object. So really what you would want is a way to do all this kind of setup as you create the object in kind of like a builder style API. And that's exactly what you can do with apply. So apply, I open a block here, and then I'll just grab these operations that are all part of the setup, and I'll move them right in here. And now you can see that what's happening here is, as I initialize my client object, I also apply all these changes. So I set the token, I make sure it's connected and authenticated. So I have now co-located all the behavior that's responsible for object initialization with the place where I'm actually initializing the object, rather than where I'm using it for the first time, which I think is a whole lot more convenient. Now, somewhat related to apply is run. If we're switching the scenario around a little and we're saying, well, so the token should always be set, but connection and authentication is something that has to happen on each individual request. Then we can use run to group the connect, authenticate, and get data function. So we could just say, all right, for my client, run the following operation: connect, authenticate, and get data. As you can see here by my type hint, the return type of run is actually the computation that happens here in this lambda. So in this case, it will be get data. So I can still get my data, but I can also do a couple of configurations the same way without having to repeat the client term. So run is used to configure an object in an ad hoc manner, and then immediately compute a result, rather than going through and just setting up the value. So here you can tell the difference between apply and run. In the return type, apply gives you back the original object, the client, whereas run gives you back the computation that you've done here, the string. So if you're actually running an operation rather than just applying a couple of changes to an object, pick run. Also, which is our second to last operation, is again used for an entirely different scenario. It's only used pretty much when you have some kind of side effects that you want to inject in a longer call chain. So in this scenario, I have a list of a couple of metals, and then I map them, I filter them, and I reverse them. What I can do with also is I can go in here and I can add some side effect functions, but also takes care of actually still passing the value that it received originally into the downstream, right? So just adding a couple of empty ones here will not actually change our behavior, but we can use it for things like, I don't know, analytics or doing a little bit of logging. So in our case here, I could just log and we could see the intermediate states where first we just get the uppercase version, and then we only get the ones that are longer than 4. So also is only used if you are also doing operations as kind of a side effect on a longer call chain. Finally, again, depending on how you count it, we look at the with function. I really like spending a little bit of time in my free time doing some graphics programming. So oftentimes you have some kind of canvas with a canvas object. And then you have these operations, right? You could write some text at a certain location, or you could draw like a circle at a given coordinate with hopefully some kind of radius. The problem is that typically it doesn't look like this. In reality, you often have just a lot of these operations, and if you're working in a larger code base, then this might be the main monitor primary buffer backed canvas. And all of a sudden, you can kind of see how that I hope you can see that there's a small issue that arises here, and that is that you're doing a lot of operations that you'd kind of like to group, but you currently have to repeat yourself. So using with, you can essentially open up a new block of code where you can call all the functions as if you were right in a member or an extension. So I can just take all of these calls, I can move them in here. They are visually separated because they're actually now part of this block. And also, I don't have to repeat the receiver every single time. Rather than that, I can access all of them directly, which is a little bit nicer, I hope. Oof. So, what first of all was described as just a bunch of functions that open a scope and have different ways of accessing things, now hopefully becomes a little bit clearer. Because you have now seen that let is only used to actually execute a block on non-null objects. You've seen that apply you use to configure objects in this builder style API where you can do it like right after you're constructing them, for example, or you're just applying some changes to an object. You use run if you're making an ad hoc configuration and then immediately computing a result. You use also for longer call chains where you're just kind of inserting some operations that are doing some kind of side effects. And you saw that with is pretty much only used to group method calls without actually having to repeat the name over and over again. Just quite nice. Of course, these were only individual examples, and I hope that just the next time you're faced with one of the problems in these categories, you might remember one of them. But of course, you'll have to practice with these things, and it'll probably take you a couple of times to get really comfortable with it. But as you go along, it'll go smoother and smoother. Now that we've introduced all of this, I want to talk about builder functions, which hopefully make at least a part of that knowledge slightly more obsolete again. Because you might, of course, in your exercises, start writing some code like, well, okay, so I have a string builder, right? So what kind of scope function would I use with this? Well, maybe I'll do run because I can append some element and then I'm immediately computing a value. But also, really, maybe I'm just grouping a bunch of append operations, all of these kind of things. Well, the beautiful thing is that in Kotlin, you don't actually have to do all this manual string builder wrangling at all. Instead, what we just have is a build string function. And again, the type signature that already is added here by the IntelliJ inlay hints gives you a bit of an idea what's going on. The build string function gives you a block in which you have a string builder, right? So I can append an element, or I can append a new line, all these kind of things. And at the end, I just get the ready baked string without having to manage the string builder by myself, which I think is quite nifty. We also have this not just for strings. We also have this for example, lists, right? So in this scenario, I'm building a list by adding a couple of elements to a mutable version, and then I get back a read-only copy. This is, I think, the most important or the most interesting part about these builders is that they limit the scope in which a mutable version of this list actually exists, right? So once you're actually done constructing the entire list using build list, it's only read-only, so you can be sure that other people aren't going to mess with that list. A nice example for this could be Here in my build map function, I'm building a prize list of gold, silver, and participant. And now if someone malicious wanted to set the price for the gold medalist to 0, they couldn't, because after the map has been constructed, it's a read-only version, so there's no set method available. We also have the same thing for sets. I don't think that's particularly interesting, so I'll skip over that and we'll go right to our last section, and that is delegated properties. Time for another sip of decaf. So, in Kotlin, we have a bunch of so-called delegates that allow you to outsource a little bit of behavior to other classes. Specifically, we are going to look at 3 different types of delegate properties, lazy, observable, and vetoable, and we're not going to do it in that order just to keep everybody on their toes. If you're not familiar with how delegates work in Kotlin, the main part that you just need to know is that whenever you have a property that's associated with a class or whatever, you can override the behavior of accessing that property. So you have custom accesses, right? You can both determine what happens when you read a variable using get or when you write to a variable using set. And that can also even have things like side effects, so you can do things like printing. There is also a mechanism using the by keyword in Kotlin that allows you to delegate this behavior of setting and getting values from a property to a different class. The exact mechanics here aren't so important. It's just important to keep in mind that this behavior can be outsourced. So, now that we are, of course, already so deep in our Kotlin knowledge, let's assume we have been promoted in our Fortune 500 company. Congratulations, everybody. And we are now in charge of monitoring the stock price for our CEO. So what we probably want to do is whenever our stock price rises, we want to tell our CEO, hey, look at the good job that we've done. Prices are up. Everything's great. And when the prices are, well, not rising, we'll see about that. So using the delegates.observable, we can actually create a variable that has an initial value of 0, and then we can provide a lambda, once again, the pattern that we've already seen a couple of times, and we can specify a lambda with essentially 3 parts. The k property, that doesn't really matter. What's important is we get the old value and the new value. So we can say if the new value is greater than the old value, what we'll do is we'll tell the CEO, and otherwise, I guess we'll just stay quiet. So now if we actually use the stock price and we increase it, for example, a couple of times, and then we have a crisis and the stock price goes down, goes up again, or it gets reduced again, then running this code, you'll see that just by accessing the variable, just by the change, because we observe all these changes, you'll see that we'll tell the CEO whenever the price increases, and when it drops, we better stay quiet. So that's kind of the power of the observable delegate. Now, because of course we've played the game of office politics so well, we've been promoted to, I don't know, working at the actual stock exchange, and now we can actually manipulate the actual values instead of just observing them. And we can do that using vetoable, because with vetoable, we now have the power of saying whether a change should be applied at all. So now we could actually go in and we could say, well, only if the new value is greater than the old value do we allow the stock price variable to be changed. So running this again, at this point, I'll have to add a couple of print statements because we're obviously no longer doing this manually. You'll actually see that even though the stock price at some point plummeted to 0, it just keeps on increasing. Only changes allowed are increasing. Okay, maybe don't do this if you work in finance. But if you're implementing, for example, like a view counter or something like this, that should always only be ever increasing. Like, it should be like monotonically increasing. Then this might be the kind of approach that you might want to take. Now, lastly, we can also still just talk about lazy. Let's assume that we have some kind of computation, and that computation takes a while. So it'll do some heavy work and then return some kind of value. If we use lazy, we can actually make sure that rather than always computing the value of our variable, so for example, of our price eagerly, that's how we would do it eagerly, we can actually say, well, only compute it when someone is actually interested in getting this variable, right? Running this code, as we would expect, no output. Because the variable is never accessed, so there's no reason in computing it. However, then if I go in and I actually print the price, then you'll see that, well, the variable is computed. It still behaves like a read-only variable in the way that if I access this multiple times, it will still only be computed once, and it'll even do this in a thread-safe manner, which is wonderful. Of course, this is a slightly contrived example just to make sure we can fit all of it on the slide. In a more realistic scenario, you could think of code that has a lot of different branches, but you have a bunch of computations that are actually only needed in specific parts of these branches. If that branch doesn't get hit, then you can just kind of move on. You can still have all your computations defined as lazy, but they will not be evaluated, so you're not actually incurring any kind of performance penalty. Wow. And with that, we have concluded what has truly been a whirlwind tour of some of the things that I thought were kind of interesting to look in the standard library that go a little bit beyond the basics. We talked about collections, we talked about scope functions, we talked about builders, and we talked about delegated properties. And I think we saw a couple of very interesting things here, right? We saw how Kotlin makes it easier to work with collections and transform them. Scope functions might not actually be as scary as when you first encounter them just because their signatures look similar. Builders might even make some of that knowledge more obsolete again. And with delegated properties, we get stock market success. Because this is only a fraction of the standard library, there's so many things that are baked into Kotlin. I, of course, encourage you to go and explore for yourself, because this is the main thing I want you to take away. If your initial thought is, okay, let me just quickly build this utility, or let me just quickly write out this loop that concatenates a bunch of text together, or that constructs something else, then maybe take a look and see, because it may have actually already been built in the standard library. With that, I'm wrapping up. If you're more interested in different kinds of Kotlin and Kotlin standard library adjacent topics, we of course invite you to also join our sibling channel, Kotlin by JetBrains, where you can see me do all kinds of funny thumbnails and cover a bunch of Kotlin topics together with my colleagues, and we also talk a little bit slower than I did during this session. So maybe check that out. Wonderful. Yeah, then thank you so much, and have a nice future with Kotlin. Take care.
Hi, Seb.
Hello.
That was amazing. So I've used Kotlin in my previous job, so I knew it a little bit, but I definitely learned a lot of new stuff. So thanks for that. And we saw some comments as well. Some people said, I just love Kotlin, I'm using it. And someone said, I need to learn Kotlin, this looks awesome. So great job. And we have a very, very important question from the chat. Do you remember the word game you were playing at the beginning?
Yes, Wordle, yeah.
Yeah, so people were trying to guess what the word was that you were going for. So can you please tell us what the word was that you were going for there?
Yes, the word is crane. And the reason why I chose the word crane is there's a 3 blue 1 brown video where he does a statistical analysis, and I believe it's one of the best starting words. So if you actually play, like if you look at the statistics, it's also like, I think 8% of Wordle players actually play crane as their opening words. It has since been surpassed by the words audio and adieu, or like adieu, like the French word, because
French.
those just cover more vowels.
Right. So those are good words to start with because they use the most vowels or the most used consonants.
Yep.
Awesome. Now I'm curious whether someone got that because we have guesses of crazy, crash, class. But I don't think anybody guessed crane. So awesome. We learned something about Kotlin and something about word games today.
Nice.
So let me see if there were any other questions to ask. Mostly just people very happy, wanting to try out Kotlin, telling us how much they loved it. So yeah, thanks for your amazing presentation.
No, wonderful. I mean, that's great. That's the entire intention is getting some eyeballs on the things that people might have not also seen, but that are all the things that made me fall in love with Kotlin in the first place. Like this
Yep.
infinite depth of just like cool things that are built in.
Yep. Well, we had Billy Corando talk about the latest Java stuff in the talk just before yours, and people were saying, "Oh, Java should really steal extension functions." So, it's good to see Java gets their inspiration from Kotlin as well. Like Billy said, they get inspiration from different languages. Yeah, amazing. Thanks so much.
It's always great, when the industry like learns from each other and things grow and hopefully things get better for everyone, like in the process.
Yes. Okay. Well, thank you so much for joining us today.
Absolutely.
And well, see you soon, I hope.
I hope so too. All right.